Which of the following shows this factored completely? Well, this is a perfect square trinomial in that we have a perfect square on the outer sides, but it's not going to factor the conjugates. If there was nothing in the middle, it'd be 3t plus 2 and 3t minus 2. The fact that there's a term in the middle doesn't change the 3t factor, or the 2 factor for that matter. It's just not a conjugate, which means the signs aren't different. In a perfect squared trinomial, the signs are always going to match that one because that's what produced the negative 12t. A negative here, negative there. That means the outer and the inner terms contributed to that middle. That's a negative 6t, another negative 6t gives you the negative 12t. So you got your minuses for both. That's a lie. Didn't even catch that. I saw the minus and that minus. So this is the conjugate I was talking about. The answer is actually C. Just be aware of that. You got to look and see perfect squares on either side. You can also go with the whole diamond in the box and the grouping thing, but that's a little bit more straightforward if you look at that first. And when you look at these, you've basically got a log of 50, which is the product of a bunch of different things. So you got the log of 50 that can be broken down into 2's and 5's. Well, you say 50 can be broken down into 2's and 5's. Well, 2 times 25 and 5 can be broken into 5 and 5. So 5 times 2 is log of 5, log of 5, log of 2. That's essentially what we're looking at there when you break it down, because when you're expanding, addition of logarithms mean you're multiplying 5 times 5 times 2. So there's your factor tree. It factors to be a 2 and a 2 5's, and so we're looking at basically the same thing here. A log of 5 is approximately a 7.7. You got 2 of those plus a 0.3. You're looking at a pretty straightforward addition there. That's 1, and there's a 0.7. So 1.7 is essentially the answer, and that's essentially 1.7.